day 2. So a small agenda for day 2 session. A very small agenda. So we start from, I hope everyone well in the basic linear regression. Anyway, the Python program execution along with and then entering into a basic revision of linear regression. Then directly you are entering into multiple regression, decision tree regression as well as decision tree classification. It's a small agenda for this day 2. So I will take a small data set for day 2. The data set was which comprising of x and y value. So the x value, I take 10 x values, that is 0 to 9. Then equivalent y value, then okay. So equivalent y value 1, 3, 2, 5, 7, 8, 8, 9, 10, 12. So this is the x and y value. So I take the sample data set. So first we are entering into Python program execution. So just I'm open a command prompt. Just opening a command prompt. So similar to yesterday's session, I'm entering into E drive. I hope everyone is fine. Then I entering into my directory. The directory was sample. So already the Python environment was set inside API / then scripts / activate. So by default, in front of equivalent / sample, the API was added. So the virtual environment was created. So now everything was fine. So the environment was ready for the programming. That's fine. Now I will open a notepad. And then I will open a simple program which is saved inside sample. The program named as py. I will open that program. I hope the program was visible. So there are 3 packages: import pandas pd. Okay. So pandas package as object pd, import numpy as np. Okay. Then matplot.pyplot as plot. So fine. So 3 packages are imported. Then the second line, I have created an array. So x1 equal to np. np is the object of numpy. So I am creating array np.array of square bracket for creating an array. The array which comprising of a value 0, 1, 2, 3, 4, 5, 7, 8, 9. Then similar way equivalent y value. So I have created an array. Yes, fine. Like this. So I have created, based on this value, I have created an array. So array named as x1 and y1 for linear regression. So now it's an array. I have converted the array into pandas data frame. So pd.dataFrame x1 is a array name, index equal to 0 to 9. So I am creating a matrix. So 0 to 9 index and its x value. Then 0 to 9 index and its y value. So I have created a 2-dimensional array, something like this. So for x, I have created a index as well as x. Similar way for y is concerned, index as well as y. So x and y are 2-dimensional matrix. So index 0 and x0, index 1 and x1. Then similar way index 2, then x2, something like this. Then similar way index 0, then y value is 1. Then index 1, then y value is 3. Index 2, then y value is 2. So similar way I have created a data frame. So x equal to pd.dataFrame of x1, index dot values. So now a data frame was created in the name of x and data frame was created in the name of y. Okay, fine. So I hope it's clear. So I will execute it in Python first. So sample. So I'm entering into Python. After that I directly execute a program. So Python. So it will open a Python prompt. So initially I will paste these 3 lines. So importing packages pandas pd, then enter, import matplotlib. Yes, so 3 packages are imported, everything was fine. Now I have added a 2 array, added first array first, x1. Okay, I have added the first array, so x1. So x1 equal to this, I have printed x1, so x1, just press enter. Yeah, it's an array. Now y1 equal to np dot array of, so now I have printed y1, so it's array. So I have created 2 array. Now convert the 2 array into pandas.pd. So x, a new variable named as x. I have printed the same. So now print x, which is a 2-dimensional array. So array of 0, 1, 2, 3, 9. So it's a separate sequential array. So it's created. So 0 is the index, then 0 is a name. So the array is created with the index. Now similar way y, I have converted into a separate frame. Now y, I have printed y. So the y values also converted into a 2-dimensional array with the index. So now everything was fine. X and y value was ready. Now I am using the third line. All are very much familiar about this line. I hope this line was very much familiar. So the entire data value, I think this is a data value 0 to 9. 80% data which is taken for X train and 20% data was taken for X test. 80% data for training and 20% data for testing. Automatically it can take a random set. I am proving it here. So I am pasting this line, importing a package. So please wait for a second. So now I have print X train. Please see here. X train, sorry, X underscore train. So please see here, the value 4, value 9, value 1, value 6, value 7, value 3, value 0 and value 5. So 8 values are taken as training. What are the remaining 4 values? Sorry, remaining 2 values? 2 and 8. I have tested again. I have again execute the same line. Now I have print X train. Now I have print X test. Okay. So if I am changing test size, if test size is equal to 3, now I have print X train. Now I have print X test. So 7 values are taken as training and 3 values are taken as testing. It's random. If I am changing random state equal to 1, if I am changing random state equal to 1, so if random state equal to true, so automatically the values was changed. Shall I execute again? Now you have for test, there test for 2, 9, here test for 2, 8. So if random test equal to 1, 2, 9, okay. So automatically if random state equal to 2, random state equal to 3, you can give anything. So automatically it can change into random. Random value was taken. Yes, fine. So okay, now I have taken random state as 0. So my X train value for 80%, so 80 values. My X test value was 20%, so 20 values. Similar way I have executed for Y train and Y test. So Y underscore train, so random value, same equivalent value was taken. For testing, I have test Y test 2 for 2, 10. Am I right? So now training was completed. Now I have fit a model. So linear regression, regressor equal to linear regression of the constructor was called regressor.fit X train, Y train. So now the model was built. Now I have predict a value Y predicted. I have predict a value Y predicted. I have print the same. Yes, Y predicted value. So now y underscore pred. So the predicted value was 3.90 as well as 10.77. So actual value was y test 2, 10. So actual value was 2, 10, but the predicted value was 10. The changes was very huge. So because we are taken only 10 samples. So y predicted value was 3.90 as well as 10.77. Y test value was 2, 7. Now for performance metrics. So these are the three metrics. One for mean absolute error. So under the package metrics, metrics dot, a method named as mean underscore absolute underscore error of. So metrics dot, metrics is a package and metrics is an object of a package sklan. So metrics dot mean underscore absolute underscore error. We are passing y test as well as y predicted. So y test is an actual value which is available in the data set. Y predicted is a predicted value based on our linear regression algorithm. Similar way, mean squared error as well as square root of mean squared error. Now I press enter. So mean absolute error was 1.34, mean square error was 2.11, root mean square error was 1.45. So for linear regression is concerned, we will take a small data set, the data set comprising of x and y value. So initially the step number 1 for importing packages. Here there are 3 major packages, one which will be called as pandas, the second one which is named as numpy, the third one which is named as matplotlib. So we are importing all the 3 packages. The second, we are directly giving a data set. So x and y value. So converting x and y value into pandas data frame, x and y. So now the step number 3 for splitting our data set into 80% for training as well as 20% for testing. So here the test size was 0.2. So x train and y train which comprising of so the data set which comprising of only 10 values. So x train, y train which comprising of 8 elements. So remaining 2 elements we are taken as x test as well as y test value. So train test split off is a method which is available inside sklan.model selection. sklan.model selection is a Python package. Inside that there is a method which will be named as train test split off. In that method we are passing x and y value which automatically split 80% for training as well as 20% for testing. Now in the same sklan package you are importing a class named as linear regression. You are importing a sample class named as linear regression. Now we are called the default constructor of linear regression class. Then the same thing which create a object named as regressor of. With the help of that object, you are called the method regressor.fit of x train, y train. Then we will find a predicted score. After that, we are comparing mean absolute error, mean squared error, and square root of mean square error. So this is a basic Python execution as well as a programming environment. So now I will cancel the same. So for executing a program, Python simple.py. For executing a Python simple.py. Yes, this Python program was executed fine. So if you are not familiar in this notepad as well as command prompt, just you have go to your browser and then type Google and then type Visual Code. Visual Code is the best IDE. So click on Visual Code and then download for Windows. So Visual Code for Windows was downloaded. After downloading, just double click and install that software, which will open like this. So the properly the color coded environment was displayed in Python. So click on that menu terminal and click new terminal. So the terminal was open. So click on that menu terminal and click new terminal. The terminal was open like this, PowerShell. So you can type yes, type then cd sample, then run your program Python simple.py. So it will display the mean absolute error, mean square error, as well as root mean square error. So the Python was executed in your IDE. Now I am entering into dataset. So it's in next part. So next, yeah, it's for dataset. Yes, is it clear now? It's a dataset. So if required, I will share a link. All those entire dataset which is available in this website. So all this entire dataset which is available in this website, the website was given to you in chat box too. So now I am entering into my next. So for example, I have downloaded in the same website, I am entering into regression folder. I click on regression folder and then I will download x16.txt. Otherwise, you can download any kind of dataset. Now the word was changed into multiple linear regression. Yeah. Now, so step number 1 for import packages. Step number 1 same. I am repeating again. Students, please listen carefully. So step number 1 for importing package. So pandas as PD, numpy np, matplot.pyplot plot. So step number 1 completed. Step number 2, I have downloaded a dataset in Google Drive. Here, if needed, all datasets are available in that website. For this example, I have downloaded a dataset from this Google Drive. So I have downloaded a dataset. This is my multiple regression dataset. Please see here. The dataset which comprising of 1, 2, 3, 4 and 5. It's an index. So except index which comprising of 5 columns. First column was petrol tax, second column was average income, third column was paved highways, so fourth column was population driver license, so fifth column was petrol consumption. So I will take this 4 column as X input. So the fifth column petrol consumption is taken as Y. So the 4 column as X, the fifth column which is taken as Y. So please see the column name, petrol underscore tax, average underscore income, paved underscore highway, population driver underscore license percentage, petrol consumption. So I will take this 4 column as X and fifth column as Y. X as input, Y as output. Now dataset equal to pd.readcsv. So path is not required if you are saving the file in the same path. So petrol consumption.csv. So dataset equal to pd.read underscore csv, petrol consumption.csv. Now the file was opened and pointed by an object named as pd. pd is an object which pointing a file named as petrol consumption.csv. So yes, next. Now preparing a data. Now x equal to dataset of, so here pd.readcsv which stored in a variable dataset. So dataset of square bracket petrol tax, it's the name of the first column, petrol underscore tax, average underscore income second column, paved highway third column, population underscore driver underscore license percentage. So otherwise you can give ILOC index location of square bracket colon comma colon -1. So except last column, all other columns which is taken as X. You can use anything. Either you can give dataset of dataset.iloc or dataset of, please see here. So dataset.iloc colon comma colon -1. So except last column, all the values are taken into X. Then last column which is taken as Y. So similar way, last column in the sense, here's last column number 0, 1, 2, 3, 4, 5. I think fifth column. So here 5. 0, 5, which is taken as y. So here in different methodology. So Python, there are collection of methods are available. You can use any one method. So y equal to data set of the last column named as petrol consumption. So now I have splitted a data set into two. One which is called as x for input, first 4 column for x, then fifth column which is taken as y. Now, so x and y are taken. Now the third step. From sklan.model selection, I have imported, I have end my slideshow here, discard. So this is a package. So this is a line. So from sklan model selection, import train test split method. So x train, x test, y test equal to train test split of x comma y, test size equal to 0.2, random state equal to 0. So now 80% data for taken as testing, 80% data was taken for training, 20% data was taken for testing. Now the training model was ready. Now linear regression, same linear regression, regressor equal to linear regression of, from sklan.linear model, import linear regression. So after that, regressor equal to call the default constructor linear regression of regressor.fit x train comma y train. Nothing was changed. The same linear regression, but one and only change was x value. We are giving 4 columns. But see, all other things are similar to linear regression. So only you are giving multiple values as input for x. So now linear regression was trained. Coefficient was not needed now. So now y prediction equal to regression dot predict of x test. So based on x test value, we are finding predicted value. So actual, it's actual value, it's a predicted score. It's actual value, it's a predicted score. Now we are printing mean absolute error, mean squared error, as well as root mean squared error. I will execute the same again. So I will open a notepad and then file, open, don't save. I am opening a program named as exercise 2. This is exercise 2. I will open my command prompt and then type Python. Yes. So player was not working. So now I am importing 3 packages. It's step number 1. I hope it's fine. So package was imported. Step number 1 was completed. Now step number 2, data set. So data set equal to, step number 2, data set equal to pd dot read underscore csv of petrol consumption dot csv. Already I have downloaded a file, the file which is available in e:/sample. So no problem. So now, yes. So for reading data set, I have read data set dot head of. So it will print only first 4 column, the header value, the entire data set header value. Data set dot describe of, which used to print the mean value of the data set, average value, standard deviation, minimum value and maximum value of data set was displayed here. So here, so dataset.head of, which used to display first 4 rows of a data set for sample heading display. Dataset.describe is used to display the average, mean value, median value, max value, minimum value of a data set. Now x and y value. So I have printed x value. So it's the index value. Here the 4 columns. First 4 column was taken. First is the index value. So index value, then petrol tax, sorry. So petrol tax, average income, paved highways, population underscore driver underscore license. So first 4 column which is taken into X. Now I have printed Y. So the value, the last column, only last column, that is petrol consumption. Only the last column. So last column, that is name is petrol consumption, which is taken as Y. Now I have used splitting 80% for training and 20% for testing. So now X train for X test, X underscore test. So only for 20%. X underscore train or 80%. Okay. Similar way Y test as well as Y train. Now I have applied linear regression. So regression model was built. Now for viewing coefficient if needed. So we choose to print the average income, petrol tax coefficient, then average income, paved way. So we choose to print the regression coefficient. So the average value of the first column, second column, third column as well as fourth column. So it's not required now. So coefficient, regression coefficient is not required. So now we have predicted a value, Y predicted value. So I have printed the same. So printed the same. The actual value was 534. The predicted value was 469. Actual value was 410. Predicted value was 545. Actual value was 577. Predicted value was 589. Now I have printed the mean square as well as mean absolute square error as well as root mean squared error. I have printed the result. The result was 56, 4,666. So error was huge, 68. So it was little bit best, not a best fit. So data set was again little. So now I am typing the same program in my Python IDE Visual Code, same program. I have executed Python ex2.py. So this was sample example of Python reading a data from dataset as well as which perform linear regression as well as multiple regression. This is a simple example for dataset. So yes, shall I repeat it again?
Yes, sir.
One second. So decision tree classification. So here there are 4 columns. So first 3 column I have considered it as X. The 4th column I have considered it as Y. So the first column refund. If refund was yes, always cheat was no. So based on this data set, this 10 rows. So I am drawing a graph. Refund was yes, the result cheat was no. Then if refund was no, if marital status was single or diverse, then a taxable income was greater than 80K, then cheat was no. Similar way, if taxable income was greater than 80K, then cheat was yes. If marital status was something married, always cheat was no. If marital status was married, always cheat was no. So if marital status was married, then cheat was no. Yes. So see, for only 10 rows, so it's very easy for building a decision tree. Then now I am giving a sample input. So I am giving a sample input. Refund was no. Marital status was married. Then taxable income was 80K. So refund was no. So which is entered here, enter here. Then marital status was married. So which is enter here. Then so the result was no. Yes. So this is for this 10 data for training, this data for testing. This 10 data for training, this data for testing. Same thing I have applied for Python program. So decision tree for regression. So the problem here is to predict the gas consumption. To predict the gas consumption in the 48th of US based task based on petrol tax, then per capita income and paved highway and the proportion of population. So that's the same. So I have taken this data set. So step number 1 for importing packages, I'm repeat fast. So step number 1 for importing package. Step number 2 for reading data from petrol consumption.csv and store it into object data set. Step number 4 for preparing data. X for data set, please read. This is another way. I location data set of, this is another way. Data set dot drop. Drop in the sense omit. Data set dot drop of petrol consumption. Except the column petrol consumption, you will take all other column as X in axis 1. Then data set of petrol consumption. So the petrol consumption column only taken as Y. This is another way. So there are different ways. All are more familiar about Python. Anyway, I am explaining different ways in separate programs. So just for fun. So X equal to data set for drop of petrol consumption. So petrol consumption column only omitted. All the other columns are taken as X. Y equal to data set of petrol consumption. Now this is a data set. So these columns are taken as X. Then this petrol consumption column which is taken as Y. Now next, sklan dot model selection import train test split of. So x train comma x test, y train comma y test equal to train test split of x comma y. Then 20% for testing, then random state equal to 0. Then 80% for training. Now data set of splitter. Now sklan dot tree. Sklan dot tree. Then the class named as decision tree regressor. Sklan dot tree class named as decision tree regressor. So regressor equal to decision tree regressor of regressor dot fit x train comma y train. Y predicted equal to regressor dot predict of x test. So the test value was passed, then find the predicted value. Now actual value was y test, predicted value was y predicted. Now which is printed. Now at last I have printed mean absolute error, mean squared error as well as root mean squared error. So based on that, which will construct a decision tree, please see here. So based on this data set, it can construct decision tree like this. Manually for constructing this decision tree was very tough. But based on this huge data set, it constructed a tree and then find the testing value, find the predicted value. Then compare predicted value with y test value. Yes, so the first one was linear regression, second one was multiple regression, third one was decision tree. So for 5 minutes, so I will take another one example. So decision tree classification. I hope students are very much clear about regression and classification. Regression in the sense, regression in the sense you can find the exact value. For example, the temperature of today or temperature of tomorrow. So classification in the sense whether the temperature is hot or cool. That's the classification. So here you are finding the petrol consumption value. In the next example, you are finding the group, whether it's in class A or class B, whether the patient having tumor or not, whether the student is pass or fail. That's called as classification. So decision tree classification. So for classification, you can take a different data set. For regression, you can take a different data set. If the data set you can find the exact value, you can go for regression. If you need to find whether the student is pass or fail, in that case, you can find classification. Now the same example, little bit modified for decision tree classification. So yes, this is my data set, variance, skewness, entropy, atasis, as well as finding a class. Whether the student in class 0 or class 1. So yes, so step number 1, I am repeating just fast. Step number 1 for importing packages, yes, same, Pandas, NumPy, as well as Matplotlib. Step number 2 for reading dataset. Here I am reading a different dataset named as bill authentication.csv. Sorry, 1 second. Dataset equal to, sorry, extremely sorry. So dataset equal to pd.read.csv, bill authentication.csv. Now, dataset.drop-off class. So except last column, all the other columns are taken as X. The last column which is taken as class column, which is taken as Y. Then train test split off X train, X test, Y train, Y test equal to train test split off X, Y, test size equal to 20. Random state is not required. It's not a mandatory. So optional field. So train test size equal to 20%. So now from sklan decision tree regressor, now here which is modified into classifier. Regressor word modified into classifier. Classifier equal to decision tree classifier. Regressor.fit, here the object name, it's any name, that's not a problem. But actually this classifier only changed. There regressor, here classifier. Classifier.fit X train, Y train, Y predict equal to classifier.predict of X test. Now, which is predicted the actual value. So actually one and only different. So if you are performing regression, then in that situation you can find absolute error, mean squared error, as well as root mean square error. But in classification is concerned, you can go for confusion matrix. That's a different performance matrix, precision, recall, F1 score, and confusion matrix. We will discuss about that tomorrow's class. That's not a problem. Now the confusion matrix was printed for printing classification report. That's fine. So day 2. So day 2. So agenda was basic Python program execution. So just I'm opening a command prompt and then set the path API/script/activate. Then I'm executing my Python program, Python filename.py. If I am executing Python program in a console, so just type Python. So the command prompt is displayed like triple greater than. Then you can copy paste the command and it works. The linear regression revision here with the help of simple array, np.array of, you are creating an array for X and Y, then converting array into Pandas data frame, and then we are working on the same. Then multiple regression, there's nothing is changed into linear regression, just X comprising of multiple column. Then decision tree regression, just a function decision tree regressor of. Then decision tree classification, it's a classification data set. You can find a student is pass or fail. So you can use decision tree classification.